I'm not a data scientist. I'm not the guy who is building data models, but I'm an application developer. So if you're like me, a person who is building apps and you want to figure out how to use all those new AI technologies, such as OpenAI, that's the session, the right session to attend. Let's jump to the topic, scalable OpenAI applications in the cloud. We are not going to have any slides today. I'm going to use Terminal, I'm going to use Visual Studio Code. My point today is just to show you, as to developers, that it's pretty simple to create meaningful generative AI application within 30 minutes. Just we want to live code a little bit. And then by coding, I want to introduce you to several scalability practices, so that if you eventually decide that you need to introduce some Gen AI capabilities to your application, services, and products, then you are already ready to know how to make them scalable, because as any other application, you would have bottlenecks, you would have scalability issues. But those can be addressed if you design and build your Gen AI applications properly. So speaking about myself, my name is Denis Magda. I've been working with distributed databases and systems for the last 8 years. Before that, I was on the Java team at Oracle building GDK, but then, you know, my life changed and I ended up in the world of databases. So that's a brutal but joyful journey anyway. And that helped, but once you nail databases, you can build sophisticated apps. That's a good outcome. So the agenda for today is pretty straightforward. First, we need to answer the simple question, what's OpenAI? What this company does and why we even have this in this presentation. Then we will quickly discuss our recommendation service. As I said, we don't want to build just a simple application. We want to build a meaningful application that, you know, serves some real use case. And while building this application, we will touch point on the scalability topic. Speaking about the cloud, because we have the cloud in the title and in the description, and first I was thinking, let's say that I would be building this application and then I will be deploying this application versions to the cloud, but then I realized two things. First, it still takes time to redeploy your application to the cloud, and second, some of you might be using AWS, some of you might be using Azure, someone might be using, let's say, private data centers, which means that instead we will be building everything on my local laptop. But then, in the end, we will summarize, all right, like you have this solution, how do you bring this to the cloud, whether that's GCP, Azure, or any other environment, let it be private or hybrid. All right, moving along the agenda. So what's OpenAI? OpenAI is the company that is behind ChatGPT. Who uses ChatGPT? Who uses ChatGPT daily, every day? Yeah, I do this all the time. Because OpenAI, the company that is behind this product, but also ChatGPT is powered by fundamental models. Like all those models, LLMs were trained on vast amounts of data that is available in the internet. And all those models are available through the ChatGPT UI, but also they are available to you as to application developers, right? And which means that effectively OpenAI is the company, right? It's the company that owns a few models, and those models are accessible via REST API. You know REST API, right? It's simple, it's developer friendly. And let's quickly iterate through those models, because right now OpenAI has 4 models for distinct use cases. The first one you already know, at least you know the acronym GPT. It stands for the Generative Pre-trained Transformer. And if you use ChatGPT daily, you probably already use ChatGPT 4, we have GPT-3, we have GPT 3.5. And eventually what that model does, it takes your text as input, your prompts, and it returns text as an output. That's it. Text input, text output. And the output text feels like magic, right? Because it sounds like we are talking to some real human being. That's GPT model. Another model is called embeddings. And this one is wonderful. Generally, like once you decide to just continue your journey in that AI world, usually we first got introduced through the ChatGPT, but then you come across embeddings. And the point of embeddings, you also provide text, like it can be your user prompt, or it can be your product description, or let's say some other text. So you have text as input, and as output you are getting vector or embedding. And vector embedding is basically an array of floating point numbers. So how does it work, right? Because we don't have the slides, but at least we need to understand some basics. Let's say we have 3 words: cat, dog, and car. And when you use some model that generates embeddings, for instance, that model can generate the following vector, the following embedding for the word cat, just because it's trained this way. For the dog, it can generate the following model, or the following embedding. And for the car, the vector can be slightly different, like -5, 10, and 11. And if you take a look at these vectors, you can see that pretty much cat and dog, they have more similarities, like vectorized representation, than the car and the dog, right? And generally, when you use those embeddings, all those models internally, they compare vectors. They compare those arrays one to each other. And pretty much when it comes to these LLMs, there are 2 primary approaches. They calculate the distance between those vectors. And distance-wise, if you compare the distance between cat and dog, it will be closer, which means that these 2 terms are more related than the distance between dog and car. And they calculate this distance using 2 approaches. The first one is Euclidean distance, like let's say the straight line between 2 points, like what's the distance, or they use angles, like angle between 2 vectors, okay? And for the LLMs, usually folks suggest to use the cosine distance. It's like cosine distance is like the angle between 2 vectors. So these are the embeddings. And quickly wrapping up, like 2 other models is DALL-E. I think that it was named after Salvador Dali. And if you want to take away any other interesting input from this presentation, I live in Tampa Bay in Florida, and we have a large museum of Salvador Dali work. So if you want to go there, if you like his work, it's a good opportunity to travel to that place. And yeah, this model, what it does, it also takes text as input and it provides image as output. And the final one is Whisper. And the Whisper takes audio and converts this audio to text. And so pretty much this is the whole portfolio of models that are right now accessible through the developer APIs of OpenAI. Okay, so today we are going to work with the following 2 models. We want to use the GPT model because that's what we know. And then we will experiment with the embeddings. So, and we will be implementing this application. So as I said, like our application is going to be a lodging recommendation service for those who are traveling to San Francisco. So let's say that here you decided to go like spend a week in San Francisco, you're searching for some nice place to stay, you want to hear some recommendations, and we want to build that, okay? So the first version of this application is going to use OpenAI Chat Completions API. So generally the same, what you have with ChatGPT, you write text, you're asking, hey, I'm traveling to San Francisco, what would you recommend me? Like, because I want to stay near the Golden Gate Bridge with a nice view of the bay, within a walkable distance to a Starbucks, etc. And we will use the same APIs, just programmatically. We will be working with the model this way. Then once we create this first version, we should notice that the latency will not be that fast, and it's highly unlikely that anybody would take this version of the application to production, because now it doesn't make sense. But it's good, as a starting point. And then we would start working on this scalability optimization. First, we will switch to the embeddings API of OpenAI. And also, we will store those embeddings. It will generate embeddings, and we will store them in PostgreSQL. PostgreSQL is a relational database. You certainly know it, at least you heard about it. And as a relational database, it's capable of skipping vectors in disk and on disk and in the memory. And it provides those basic operations to calculate the distance between different vectors, and effectively you can use it for the similarity search. So why Postgres? Because I work with the Postgres community, and like this database is very capable, and generally speaking, I don't have anything against the vectorized databases. You can use your favorite vectorized database, but I'm a believer that usually most of the use cases will go beyond just a GenAI, approach. Usually you would need to have some real customer data. You would need to join this data with some, something GenAI related, and relational databases already have all those capabilities. You just need to add extra add-on. So you will see that with that second version, our application will become much, much smoother and faster. And then we will start thinking, all right, what goes next? Like, how else can we make this thing scalable? We will be able to optimize with indexes, because indexes, like usually in databases, when you have a bottleneck, first you need to check the execution plan, and if it's like if you apply all the optimization, then probably it's a good time to create an index. So also there are different types of indexes that exist for embeddings, for those arrays of vectors. We will take a look. And finally, sometimes you can be dealing with gigabytes or terabytes of different data, with terabytes or gigabytes of embeddings, which means that you can outgrow the capacity of your single database server, and you might need to switch to a distributed database. And in this case, I will be using Yugabyte DB as a reference platform, because Yugabyte DB is distributed Postgres, which means that if you start with Postgres, and then at some point you need horizontal scalability, you need more CPU, so you need high availability, it's just a quick transitioning for you, all right? So that's the plan. Let's build this application, and as we will be building this application, we will be using two models of OpenAI, GPT and then embeddings. And we'll see if I don't screw up, then by the end of this session, we will have this fourth version of the application working, all right? Let's go. So the code, the application, at least I have the template. So this is how the application looks like. That's our user, some of our users who are lucky enough to travel to San Francisco, and that's our application, that's a React and Node.js application. Generally speaking, why I picked JavaScript? My favorite and my default two languages are Java and C, but I recognize that JavaScript is intuitive enough for anybody to understand the code, which means that if you code in Python or like Rust or Java, etc., or C#, it's like you would certainly understand JavaScript, right? And then you can just take the same practices and implement an application in your favorite language. But anyway, so our users will be connecting to the React frontend, and then that React frontend will be taking this user prompt. The user, let's say, I'm going to San Francisco, I want to stay near the Fisherman Wharf, etc., to see the sea lions. And then the application will support two modes. The first mode is the OpenAI chat mode, meaning that we will take this user prompt as is, without any modifications, and we will send this prompt to this AI somewhere in the cloud, OpenAI. And then the AI will return us recommendations, and we will display those recommendations on screen. And then the second mode that we want to implement ultimately is Postgres embeddings mode. Again, we will take, what's the difference here? We will not discontinue OpenAI. We will be taking user prompt. For that user prompt, we will be generating a vector embedding, and then we will use this embedding to do a vector search or a similarity search in the database. In the database, in this case, we will use two databases, Postgres and Yugabyte DB. The database will be storing a subset of the Airbnb data for San Francisco. Yes, like you can Google and you can find a subset of Airbnb data for San Francisco. And I already generated embeddings for the properties description, which means that we will take this user prompt and we'll run a search against the embeddings for the Airbnb lodging options. And then we will see like where should we stay depending on our preferences. Make sense? Now, so where is my code? So my code is here. So let's open it up. So let's make it bigger. Good enough. Good. Okay, that's the properties. So we are not going, like the first version is not using database at all, but nevertheless, I have Postgres running on my local laptop. And then in the end, we'll discuss how you can run Postgres in the cloud probably. Who already uses Postgres? All right, I mean like half of the crowd. So let's stop talking about Postgres then. So that's the backend. The backend has just one REST API endpoint called search. The front end will send the request. The request will come with two parameters. The first is my prompt, whatever I will be typing in the browser. And then the engine parameter, basically, that's the mode. Because the backend, remember, has two modes. If the engine or mode is equal to Postgres, then we will be calling the Postgres service implementation for this application. Otherwise, we will be calling the chat completions API of OpenAI, just GPT model, okay? So let's go to the first one, because we want to start without any Postgres, without any database. And so here is we have an empty file, we need to implement it. So, you know, like, I'm using JavaScript, but like I have that kind of practice of creating, like turning everything into an object relational mapping. So like when I was creating this application, I turned everything into a class. It's like, it looks like an object related stuff. So sorry, like it could have looked simpler, but nevertheless, we have constructor, we have all this stuff, and we connected to the OpenAI. I have this OpenAI key. And here is our method that we need to implement. So how do we implement it? So let's first, the implementation is straightforward. You have the user prompt, and you need to, that's the text, and you need to connect to the OpenAI and get recommendations. So, right. I'm using also GitHub Copilot. I love it. I mean, like at least it replaces me the need to go to the documentation all the times. But it's not perfect yet, as if you attended, even today's keynote session, you need, think about it this way. That's a junior developer who is very knowledgeable. The developer is just fresh out of college, very knowledgeable, knows a lot, learned a lot, but still, you need to be a senior. You need to check like what's being suggested to you, but still, it's very helpful. And here is like, I already know that this model of Copilot was trained on a stale subset of OpenAI API. I know that the API endpoint is different. OpenAI completions, chat completions, create. Yeah, we are creating this request, and we need to pass a JSON with parameters. So one of the parameters is messages. So this is what you do, right? If you use ChatGPT, you type in message, and then you're getting something in return. But when you do this programmatically, ideally, you need to provide a system message, and the system message kind of gives a hint to the model. What do you expect from this model, right? So what you want the model to do. And in my case, yeah, I have the system message as follows. I have this message, the role is system, that's the official API of the company, and then you pass the content. The content, what the content says, hey, you're a helpful assistant, you help folks to find lodging in San Francisco, at least suggest 3 options and send back a JSON object in the following format. I'm telling like the name of the property, the description, and the price, and then just in case I'm telling you, just send this JSON back, nothing else, because if you use ChatGPT, it will follow your final instruction. If you use GPT 3.5, this will not work. And you would actually need to get this response, and you would need to subtract JSON from the return text. But for the GPT-4, this system message works. And so once, and this context is not visible, this is what you want the model to do. The next step is to provide the user message. The user message would be the role. The role is user, and the content is prompt. Yeah, that's the user prompt. So what else? We have the message, and then if you return, if you want to send the request, you need to provide the model. The model is going to be GPT-4. So that's it. We are creating this chat completion request. We are telling the AI what we expect from it, and we are sending the user prompt. That's it. So once the request is processed, constant completions, constant, and after that we want to, yeah, it's like, you are almost right, my dear. It's completion choices. It comes with several choices, but I know that in this example I have only one choice. Just it's an array of choices, but I have one choice, and then we have what? We have it has the message and it has the content. Hopefully my memory doesn't fail me, but we'll see. And then yes, like here as you see that Copilot is very useful. Yeah, then I want, because it remembers I'm expecting JSON somehow. This is the magic. And it converts this response to the JSON. And then I want to, actually no, I want to just to assign it to places, because these places is the JSON that I need to return. And just in case, let's put down into the log. Yep, so that's it. Fingers crossed. Let's start our application. So we have the backend. The backend is here. Just npm start. Started. So what else? Split the terminal. Yeah, because I want to start the front end. I'm going to the front end. The front end is here, and the command is the same. Come on. How do you like this UI? Actually, I spent like 3 hours, and I had to follow the advice of those who say, just ask Copilot or any other open source model to generate the code for you. Because one of the reasons why I ended up on the Java team in the early of my career is because I was building like those scalable web applications, and I had to write code in Java GSP pages, and it was a mix of styles, etc. I disliked it so much that I went to the product development, to the APIs development. But nevertheless, so we have this OpenAI chat mode that we have just implemented. We have the Postgres embeddings mode. It's not implemented yet. So let's say that I want to stay near the Golden Gate Bridge with a nice view of the bay. All right, show me an exception. Oh, no exception. So you see this Pac-Man eating the bubbles, which means that the request is traveling to the cloud, to the OpenAI, and usually it takes 10 or 15 seconds to get the recommendations, right? Yeah, my memory didn't fail me, and we've got some recommendations here, like we have Cavallo Point, is just a moment from Golden Gate Bridge. Yeah, we have something near the Fisherman Wharf. Nice, and like, the price is high, especially for this one, but this one probably looks decent for San Francisco. One thing to keep in mind, GPT was trained on stale data, which means don't pay attention to the price, because GPT-4 was trained on the 2-year-old subset. It's like September 2021. But if you use ChatGPT daily, or like weekly, once in a while, that that OpenAI supports plugins, and Expedia already supports plugin. So you can enable plugins, and you can search through the real-time and the current information. But those plugins are not available for developers, unfortunately. Like, you cannot use Expedia plugin, at least yet, programmatically. So what I don't like about this, let's do this once again. You see this Pac-Man, and the Pac-Man will be eating those bubbles for a while and can blow it like really fast if there was some animation. And we don't like this, right? That's not scalable. We definitely have some bottleneck, and the bottleneck is OpenAI GPT model, because it's very powerful, it's very knowledgeable, but it's way too generic for us, and it takes time to process our requests, because we are not the only one who uses this GPT model right now. So we want to optimize, we want to make this scalable. And as I said, the first way is, let's say that we have our own data set. Usually we work for the companies, we create applications for real products, services, and goods, which means that we own some data, right? And some of the columns, some of the fields of that data can be used to generate embeddings, and then you can do that similarity search. And in our case, as I said, we have Airbnb data set for let me do it this way. We have the Airbnb data set for San Francisco. We have this one table, Airbnb. No, we have Airbnb table. It comes with more than 100 columns, but that's going to be enough for us. Yeah, let's create a new script. So let me show you what's inside. We have many columns, but pretty much it's enough to have the description from Airbnb listing. We have many, and we have this description, and these descriptions alone, I mean, that's a nice candidate for Gen application. Like, you can take this description and you can generate an embedding for every description, like that vector. And then when you're doing the similarity search, you will be comparing a vector generated for your user prompt against the vectors generated for your descriptions, like for the descriptions of your Airbnb properties. So in my case, yeah, let's return at least 2. And I've already did this job because, and I will explain you why we are not going to generate those embeddings in real time, because nevertheless, we will be using that API, the same API, but to generate embedding for our user request. And generally speaking, it takes time. It took me, let's say, 15 minutes to generate embeddings for their more than 7,000 Airbnb listings for San Francisco. But this is how an embedding looks like. It's just a long array. It's just, it's very long. It depends on the model. OpenAI embeddings model generates a 1,536 dimensional vector. Like, we live in a 3-dimensional world, but this model generates like 1,536 dimensional vector. And it depends on the model. If you're going to use another model like open source models, some of them generate 300 dimensional, 600 dimensional vectors. This one is very powerful. So we already have the data needed, right? So what we need to do is to advance our application. Where is my source code? So this is my source code. So here is, that's the search method that I need to implement. Again, we are going to use OpenAI, and we are going to use our database. We already have the table with the Airbnb data there. So now this time, let's say what we do, not completions, we want to use embeddings response. And for that, that's an asynchronous request. We will continue using our, what we have. Yeah, we have this OpenAI, not answers, embeddings create. Just the name of the model, embeddings, it's all intuitive. And we need to pass a JSON with parameters. So here is OpenAI embedding model. Yeah, it's called embedding model. I don't remember the name of the model, but this one is text embedding ADA 002, like second generation of this model. And as for the input, just user prompt. Simpler, right? Just less movements. You don't need to provide any context. But here is to make this solution working, you need to own your data set, and you need to decide what column, what part of your data set you want to convert to an embedding, right? So once you get this response back from OpenAI, we need to connect to the database, and the database will return rows. This client create request. No, not create, query. Yeah, select from, not select from, select but not from places. So unfortunately, it's going to be a little bit more advanced. So you remember what our front end expects from us: a name, description, price. Oh, wonderful, almost everything. No, not embedding, we don't need embedding. And the name of the table is, if you remember, Airbnb listing, right? And then, but that's not it, because we don't want everything. We want what we want. We want where, okay. So now let's fix this query. We need to calculate the distance. And we know that we have the description embedding. That's the name of the field that keeps embeddings for our Airbnb descriptions. And we want to calculate the distance. This is the Euclidean distance, but we want to use the cosine distance, like the angle, cosine between two vectors, between two embeddings. And we are going to compare to the embedding of the user prompt. It's going to be passed as a parameter, because we don't want to have SQL injections just in case. But here is, we have this matching threshold. Yes, you can calculate the distance and then range, or you can judge by the similarity. If you want to have the similarity, you can do this 1 minus this distance, and you will get the similarity, and this one needs to be bigger than second parameter. The second parameter is going to be our matching threshold. So the similarity range would be between 0 and 1, closer to 0, closer to 1, better, meaning that if your similarity of the user prompt and Airbnb description is 1, that's the perfect match. Usually, it's never 1. It's between, let's say, 0.9, 0.8, etc. And then once we do this, we want to order by the similarity, because we want the most similar, the most related suggestions to go first. For that, let me do this exercise. I will go here, and I will add another column as similarity. And I will order by similarity, descending. This one we don't need. And limit, how many suggestions do we want? Just depends on this parameter. This parameter, I will show you, it should be asking at least three options. All right, and then we have these 3 arguments that we need to pass into the query. What do we have? Yeah, it's an array. So what we need to do, we need to do a little hack, because This is what PG vector of Postgres expects. We need to pass it as an array here, and embedding response is stored in data array. And I know that there are going to be just one embedding, matching threshold and matching count. Those parameters are passed from here. And so right now, if you take a look here, so we want to get only those suggestions that have this 0.7 similarity with the user prompt. It's a pretty good one. We can increase it to 0.8, let's do 0.8, and we want to have 3 suggestions. Done. So we get those rows. So what do we do next? Await, yeah, it's actually good. That's also an asynchronous request. Let's block there. Once we get those rows, for each we have rows, right? We have rows, and for each row, we just want to add every row to our array of places. So we have places, and we want to push this JSON. What we have? We have row name, row description, row price, something. Yeah. We have row name. We have name, right? It needs to be this way. We have name. We have description. We have price. So, and also we have the similarity, right? You remember we have the similarity. We want to see how similar the Airbnb property is to our user prompt. Row similarity. All right, looks like we are done. Let's check it. I guess that I should get an exception, but what we need to do, we need to restart our backend. So let's restart the backend. Where is my UI? We are going here. We are running this request. And I've got an exception. Yeah, that's expected. So what's wrong here? Rows. So it cannot handle it this way. What do you mean? Rows for each is not a function. That's strange. What do I mean? All right, so let's change it to this way. No, it looks all right. All right, how about we do it this way? I don't know what's wrong with this one. Yep, we can do it the old-fashioned way. Yeah, this seems about, no. Yeah, this way. Okay, let's give it a try. Restarting. Okay, we've got something back. It was much faster, right? Just less than a second. And this is the similarity. You see, like I wanted to stay near the Golden Gate Bridge. Yeah, there is some Airbnb property, Russian Hill neighborhood, Golden Gate Bridge, and this one is, yeah, has a good match according to the model. And generally, one rule you need to keep in mind, because in this source code, I was using the OpenAI embeddings, this model, and the embeddings for the Airbnb descriptions were generated with the same model. So that's the rule of thumb. If you use one model for your data set, then you need to use the same model for your user prompts or for another text that you want to compare to. Finally, so we've got this working, and so what next? So how else can we optimize our applications? You have vectors, you have indexes. Because right now I have just 7,500 Airbnb listings, and the search is fast. But whenever you run this request, this is a full table scan, meaning that we need to compare the user embedding to more than 7,000 embeddings, like 1,000 plus dimensional embeddings stored in the database. It's fast even on my laptop, but imagine that you have like hundreds and thousands of users running this request, or you have much larger data set. It's not scalable. So if you want to make it more scalable, you want to create an index. So for instance, one of the indexes, when you create an index, basically in this world, they have this ANN. It stands for the approximate nearest neighbor. This is like one of the problems in the graph theory that you need to solve. And generally, when you're searching for the closest similar or related suggestions for the user, then you need to solve this problem. And those indexes, some of the indexes solve it. One of the popular indexes that exists for their vectors is HNSW. It stands for the hierarchical navigable small world index. So let's start creating it, because it will take almost a minute to create this index. And while it's being created using HNS, yeah, it's being created right now. You can see this counter. The time is going by. So how this index works, as I said, if you want to dive into the details, you can find content created by other guys. You can think about these embeddings like those vectors. Like, let's try to squeeze everything to one dimension, like a two-dimensional world. So you can pinpoint every vector like to a plane. And then when you build this index, it's like hierarchical navigable small world. You have several layers. The first layer is sparse. It comes with several points. You pick some of the points, and then for each point you find the nearest neighbor. You connect them. You need to build the graph. So actually, HNSW is the graph search. You need to iterate the graph to find, let's say, the most accurate, let's say, suggestions for the user prompt. And then, like, once you pick the first points at the higher level, then you go down for every point from that higher level. You go to the next layer where you have more points, and then you repeat this process. And the next level, you're also finding, let's say, the nearest points, and then you continue this until you get to the next point. And you kind of, and this exercise takes time, which means that this parameter if construction means that how many nearest neighbors do you want to have for every point, like, of your vector, right? And you don't want to have this number big, because right now this number is 10, which means that, like, for every point, like, of that vector, you want to find the 10 nearest neighbors, and it's time consuming to build this graph. And this second parameter M, it's used during the search. When you have your user prompt, you start the search through this graph, and it says that, like, at every layer, like, you're starting from the sparse one and you go into the denser one, you want to find up to 4 nearest points. So this index is lossy, meaning that you might have some false positives. You are not expected probably to get, the most accurate response. But here you are dealing with the trade-off between the accuracy of your search and the time it takes to build the index, to maintain this index, right? It takes time. But generally speaking, you start with these parameters, and then you can experiment and you can fine-tune, like, depending on your data set. So this is how you create this index. And generally, then the database will decide when to use which index. So as long as this data set right now is small, we can just certainly run this request and this request, or you can create something else. Let's say I want to stay near the, I don't know, what do we have? I want to stay in Chinatown, in San Francisco. It might be using index, it might be not. We can check it using the explain query of database, but it doesn't matter. The database will decide when to use the index. Usually when your database is, volume is large, the database will be using the index, and you will be getting the logarithmic complexity instead of the linear complexity, search complexity. So keep this in mind, right? Once you hit the bottleneck, because usually when you build those scalable applications, whether GenAI applications or any other applications, quite frequently your database data layer becomes the bottleneck. So that's why we optimize this. Now we have the data stored in Postgres, and we use pgvector, we store embeddings. Just in case we already know how to use indexes, one of the most popular right now is HNSW. So what next? If you outgrow the capacity of your database, right? Or you have like gigabytes or even terabytes of data embedded stored in your database. You just want to scale to get more storage, to get more CPUs, and just to distribute the read and write workloads. Let's use Yugabyte DB. I've started Yugabyte DB. Same as Postgres, Yugabyte DB is fully open source, Apache 2.0, all the features are open. I created, I studied it. It's written in C, same as Postgres. It's written in C++, which means that you can run it on any Unix operating system, or you can run it in Windows and Docker if you want. So I have a 3-node cluster. I have the same database in here, Airbnb listing. All the data is sharded, meaning that I have those 3 nodes. The table is split into shards, and those shards are distributed across the nodes, meaning that every node will be keeping a subset of the data, and every node will be handling read and write requests. So if we go here, you remember I have this request. Where is my request? Description embedding. Yugabyte DB is Postgres compatible, meaning that the query layer of Yugabyte DB is Postgres. It's just Postgres source code, Postgres that became distributed, which means that I'm using Postgres drivers, libraries, and frameworks to work with Yugabyte DB. And here is, that's a request against Yugabyte DB. We have descriptions. We also have embeddings that were generated similarly. No any difference. And what do we do with our application? We have 4 minutes, but the switch is going to take less than a minute, I hope. So effectively, what you need to do, like in most of the time that's the case, you just need to change their connection address. So I have also Yugabyte DB running on my laptop on a different port number, and I created this Airbnb listing table in the database named Yugabyte DB. The username is Yugabyte. And I'm very creative. The password is also Yugabyte, so that I don't forget. That's it. And this next step, I need to restart. I want to go to Chinatown. Yeah, and right now these queries go to Yugabyte, and you don't see any difference. Which means that if you don't see any difference right now, it's good, because at least the latency is comparable, even for this tiny data set. But once you have large data set, you will be able to exploit, distributed database. All right. So wrapping up, we managed to figure out what's OpenAI. The company creates models. All those models are accessible via REST API. We use today GPT model, embeddings model, and we created the application using first version chat completions. Then we used embeddings. Then we created indexes. You know that, keep in mind indexes. And then if you need to large volume of data, embeddings, etc., you have Yugabyte DB. Where is the cloud? That's a good question. The cloud, OpenAI. That's a cloud service, right? It's already in the cloud. And actually, as you know, like Azure owns half of the company, and they also have their own fork called Azure OpenAI. But nevertheless, I used OpenAI as an example, but don't be restricted. Any other cloud provider has its own GenAI model. It's accessible. And you have LangChain, you have open source models. They're all accessible. It's up to you. OpenAI is used as an example, at least because everyone knows ChatGPT. Then we used Postgres. Like Postgres is a database engine, and like Postgres right now growing like very fast. And every cloud provider has offering for Postgres, right? Or you can run it yourself. You can use Amazon RDS, Azure for SQL, Google Cloud SQL for Postgres. It all exists. Pick the one you like, depending on your cloud environment. Similarly, Yugabyte DB, right? I was running on my local laptop, same as Postgres, but if you like, we have Yugabyte DB managed that also can be used in any of those cloud environments. That's it. So we are done. And if you find this useful, as I said, just Google. It's literally simple to build this stuff. And at some point, if your company decides to introduce GenAI apps, just today you saw that it's pretty much easy to build within literally 30 minutes. But keep in mind the scalability, right? Because once you bring them to production, you will get hundreds and thousands of users hitting your application. You want to be able to withstand the traffic and to grow and to bring value to your customers. So thanks for coming, and I think that we have only 1 minute left. Probably one question, and then I will be happy to take questions off the stage. Yeah, you can find me. My name is Denis Magda, and you can find me on Twitter, or you can find me on LinkedIn. Yep, thanks for the hint. Yeah, and I'm just the guy who likes databases, but I like databases as a developer. So if you're interested in databases, that's my primary topic, so how to use databases. Thanks for coming. Enjoy the rest of the conference.